Dear guys, Assalamu alaikum. My name is Mohammad Gashuddin. Today I will discuss about 10 chapter of first paper, okay? And I will discuss about some equations which are written here on this whiteboard. Please try to understand and try to listen to me what I say and stick to me from first to last. Dear guys, theta equal to theta 1 minus g theta 1. Theta 1 minus g, theta 1 minus theta 2. Here guys, theta is due temperature and theta 1 is temperature of dry bulb. Okay, and theta 2 is temperature of wet bulb, and g is glacial constant factors. Glacial factors. So question will give this actually. R equal to F over capital F multiple 100%. Okay. Yeah, actually, what do you mean by F? F means saturated vapor. Okay, saturated vapor pressure at dew point. Saturated vapor pressure at dew point. Okay, and F is the saturated vapor pressure at the temperature of the air. At the temperature of the okay, and if you know this, F over capital F multiple 100%. R is a relative humidity. Relative humidity. And if you know this and this, and you can find out this. And if you know theta 1 g, theta 2, you can find out the dew temperature. Okay. Lambda equal to 1 over n pi sigma square. Sigma square is actually, what is the sigma square? Sigma is the diameter of the molecule. Diameter of the molecule. And n is the number of molecule. And then there is the mean free path. Lambda is the mean free path. C bar square root equal to root 3 kT over capital M. The rest here actually you have to understand. This is actually root mean square velocity. Root mean square velocity of gas. And K is Boltzmann constant, T is temperature, M is the mass of the gas. Okay. And Boltzmann constant value K equal to 1.38 into 10 to the power minus 23 joule per Kelvin. Okay. And if you know this K, T, M, you can find out the root mean is the velocity. Here is the average energy T over 2 kT. My question will say about average velocity, then 3 over 2 kT. We'll use kT formula. K here Boltzmann constant. Here Boltzmann constant which is value 1.38 into 10 to the minus 23 joule per Kelvin. Okay, 1.38 into 10 to the power minus 23 joule per Kelvin. Boltzmann gas constant. Okay, and another formula E equal to 3 over 2 RT. One question say about the energy, then you apply this formula. E equal to 3 over 2 RT. R is universal gas constant. R is universal gas constant, which value 8.31 into 10 to the power 8.31 into 31 joule mole per Kelvin. Okay, the value of R equal to 8.31 joule per mole per Kelvin. Again I say R equal to 8.31 joule per mole per Kelvin. But Boltzmann constant joule per Kelvin. Joule per Kelvin. And value is 1.38 into 10 to the minus 23. Here 10 to the minus 23. 1.38. Here 8.31. Okay. Try to difference between this actually equal to 3 over 2 RT. When you get R and T, you can find out that energy. When you get the KT, you can evaluate the energy. Okay, P equal to 1 over 3 rho C bar square. Okay, if you square average square velocity. Okay, if you know the density and C, you can find out the P. P equal to over 3 1 over 3 M and C bar square. Okay, here M is the mass and is the mass of per molecule and is the number of molecule, and C is the velocity. If you know M and C, you can find out P. Okay, if you know just rho, you can find out P equal to 1 by 3 rho C bar square. PV equal to 1 by 3 M C bar square. M and C bar square. Yeah, if you know M, capital N, number of molecule. M is the mass of each molecule. C is the actually velocity of this square velocity of the P pressure is volume. T special, this volume. Rho 1 over P1 T1, okay, equal to rho 2 over P2 T2. Dear guys, here rho 1 velocity, rho 1 density, okay. First situation, and rho 2 density, okay. Second situation, P1 pressure, T1 temperature, okay. And so if you know rho 1, rho 2, P1, T2, P2, you can find out T2. Actually, you have to remember this equation. PV equal to nRT. Very important. N is the mole number. Its universal gas constant is value is 8.31 joule per mole per Kelvin. Okay, 8.31 joule per mole per Kelvin. PV equal to nRT. If you know nRT, you can find out PV. Okay, and if question gives you V nRT, you can find out P. M over capital nRT. This formula you have to. This equation you have to remember. Here N is the molecular mass, and capital small m is the mass which question will give. Okay, of any substance. Small m over capital M. RT. Here universal gas constant, and T is the temperature. You know universal gas constant value is 8.31 joule per mole per Kelvin. Okay, if you know small m, capital M, RT, you can find out PV. Okay, and P1 B1 over T1 equal to P2 B2 over T2. Okay, if you know B1 B1 T1 P2 B2, you can find out. Actually, if there are given 5 values of quantity, you can find out the remaining quantity. P1 B1 equal to P2 B equal to K. V equal to V naught over bracket 1 plus theta over 273. V equal to V naught bracket 1 plus theta over 273. Yeah, guys. Again I say this is actually theta equal to theta 1 minus G, theta 1 minus theta 2. If you remember this equation, I guess you can solve any type of problem related to this chapter. Actually, that's why you have to understand meaning of each letter is symbol. Okay, and again I say R equal to small f over capital multiply 100%. Actually here F is situated vapor pressure at dew point, and capital F situated vapor pressure at the temperature of the ER. Okay, and sigma equal to 1 over N pi sigma square root C bar square root to root 3 kg over capital M. E bar equal to 3 by 2 kg. E equal to 3 by 2 RT. Okay. Actually, you can apply this here R. P equal to 1 by 3 rho C bar square. P equal to 1 by 3 N and C bar square. Okay. And P equal to 1 by 3 small m capital N C bar square. Rho 1 over P1 T1 equal to rho 2 over P2 T2, and PV equal to an RT equal to an RT equal to small m over capital M RT. P1 B1 over T, P1 equal to P2 B2 over T2. Okay, and another formula P1 B1 equal to P2 B2 K. V equal to V naught plus bracket 1 plus theta over 273, and Boltzmann constant value 1.K. 1.380 to 10 to the power minus 23 joule per Kelvin. R, that is universal gas constant, are equal to 8.31 joule per mole per Kelvin. And glacier factors question will give, and if you press remember this equation and try to solve various type of problem related to this chapter. Thanks a lot.